out at a couple of oil rigs, but the black swan, a black swan, is basically
An
it's
example.
it's an example. So it comes from, it's used many places, but the idea comes from, like, let's say you contended that all swans are white. You know, you've only seen white swans, and you say all swans are white, right?
Yeah.
And I say wrong. Some swans can be black.
Yeah.
Now we're in contention. All I have to do is provide you one black swan
And
to
it's
prove
proof.
you wrong.
Absolutely.
Right? Yeah. Well, that's what this is. So it has to do with Modus Tollens argument. It has to do with the geometry, the radius of the Earth that we're given of 3959, miles. There's a geometric limit to which you should see things on the Earth, and all we have to do is disprove it one time to disprove your radius. And yes, this image is called the Black Swan. Yes, we've disproved your radius with it, but it is not the only black swan. There are many, many black swans.
Well, when you're walking along, or if you know the distance of places that you can see, you're looking at black swans. Whenever you see something that you know is too far, that's a black swan. So they're everywhere. If you can know the distance.
Well,
What's up?
Perhaps Lou would have. Perhaps he wanted, to know that the guy actually took what he said in.
I'm taking it in.
Go ahead. Yeah, go ahead. What do you think, PJ? Sorry, man.
I mean, I feel like the Black Swan argument definitely applies to some things. But not everything, does it? Does it apply to everything?
So lay out the argument, and then...
Of what? Yeah, something that would be similar to a Black Swan.
Lou, go ahead and just lay out the actual argument.
Well, yeah, no, I laid it out pretty distinctly.
No, exactly. So it's if someone is
an opposing, like a way to refute the black swan, an example where a black swan doesn't fit reality. So, like, somehow, if I were to say that, if I was to say that all swans are white, and you were to say no, some swans are black, how does it work?
Well, I'm sorry, Lou, but this is what I meant was, because if I ask him what is the argument, is he going to be able to repeat it based on what you've told him thus far? Like, as far as like the actual observation in front of him, because that's what he's asking. So perhaps he doesn't understand the argument.
I understand the argument.
What's the argument?
Oh, the Black Swan argument or the curvature argument?
What's the argument about the horizon?
In relation to flat Earth. Oh, is that yeah? So in some places you can see that you can see much further than 23 miles. It's like max.
He doesn't know the argument.
What argument? Wait, as in of saying that it's 8 inches per mile.
8 inches per mile squared, meaning that, like, if you are on the beach, if you're on the beach with your toes in the water and you're 6 feet tall, the farthest you should see is
23 miles or something. It's weird.
No, it's like 2 or 3 miles, like not 20.
2 or 3 miles.
2 or 3 miles, yeah.
Wild, yeah, that's way too little.
I mean, well, okay, well,
you can see further.
3 to 5. 2 is a little short, but if you're a 1 foot observer, let's say you laid down on the sand, you laid down on the sand right in front of the water. That's what the Black Swan basically is. The Black Swan is with a camera that's laid down on the sand. So if you have your head,
so that's not true. It's 1 foot off the ground to 5 feet off the ground. So it's not on the sand. It's 1 foot above the ground.
Yeah.
No, the tripod is set to low right at the water's edge.
which is
So,
1 foot off the ground.
one
Jeff.
foot off the ground,
If,
right?
if you have your head, like your chin is on the sand.
Yeah,
Okay.
I think he meant like if someone's lying down and with a camera to their head, it's going to be about a foot off the ground. That's
Right.
what I pictured. But you to be
That's what I was
clarifying.
describing. That's what I
So
was,
just to clarify, so the geometric
no,
ball,
clarification is good.
the geometric ball calculates that at 1 foot observer height, the horizon is 1.22459 miles away. This is claiming that any observer putting their head close to the ground, the supposed edge of the sphere or where objects appear to go down is as little as 1.2 miles away.
This is that geometric
Yeah.
horizon.
Well,
curvature
this
we were
is-
talking
this
about.
is-
I appreciate it, and if you want to jump in a minute, that's great. But yeah, for clarification purposes, what I am describing is like what you just said. It's 1 foot off of the sand, or if you were holding a camera, laying in a prone position, you still
Yeah.
wouldn't have it at like in the sand, right? You would be
For sure.
above, right? You would be let's say 1 foot above the water. Okay. So if you're 1 foot above the water, you should only see 1.225 miles out until the horizon. Anything that's above the horizon, like taller than 0 feet tall, will still be seen, but the bottom of it will start to get cut off there. If you're 6 feet tall, it's what 72 inches or something like that. It amounts to, and again, depending on like refractive indexes and stuff like that, you should see between like 3 miles is about right. Like you might be able to see if you include refraction, like 5 miles. But the Black Swan, what we're talking about is over 6 miles, almost 7 miles to the very first rig, and from 1 foot, which remember is 1.225. And then the second rig is almost 10 miles, 9.7 or something like that. That one is a magnitude of a difference for how far you should be allowed to see. And then if you go beyond that,
You can zoom past it because it's caused by refraction and the diffraction limit. So when a camera zooms in, you decompress the image by opening it up, reversing the diffraction limit, and then seeing farther into the distance. Fundamentally, it's all done by refraction of light through the lens. So all these images that you see through a camera that are zoomed in is zooming in using refraction. So there are seeing past the observer, you and me, human eye, the camera's seeing past that, highlighting that it's not a physical location. It's an apparent junction based on the limitation of light to your eye. But when you use a camera and you zoom in, you're actually opening up that angle, you're reversing the compression, but you're still subjected to refraction, diffraction, and the angular limit to it. So just to highlight that, that's why the camera is seeing past the 1.22, because it's not a physical geometrical edge.
to point out, the only rebuttal that you could have, which is a terrible one, so I'm glad you haven't said it, is to just spout out the word refraction. And if you were to do that, you would be basically saying that what you are seeing is not real. Okay? Like, it would have to be a mirage of some type. It's not really there. But we get extreme detail on these things. Like when it comes to a mirage, they're wavy, or they're inverted, or there's all kinds of attributes that we can give to mirages, and these do not have any of those attributes.
So fundamentally, the
radius.
It's all going to be about light. Whether it's diffracting or refracting, it's going to come down to the angle of light bouncing off the object to the eye. The reason why the 1.22 is used in this example, it's because it's based on the angular limit to the eye. The hijacking is done through the eye. In other words, whatever we see in our local field of view has been hijacked into a ball. And one way to see how the geometric ball does not work is seeing farther than the geometric constant, farther than 1.22 could be actually 1.32 miles away. You're still seeing farther than that geometric limitation called the horizon in the geometrical calculator.
Yeah, and to show what you're saying is correct, you can look at all Earth curve calculators and notice that the heights of the objects that you put in are considered like the real height of the object, not the apparent height, which is what you're going to be comparing it to, because everything we see, every picture is through perspective. Everything appears to get smaller with distance, but with the Earth curve calculators, they exclude perspective and change it into Earth curve.
Nothing to do with the angular light or refraction of light. They're conflating the angular limit and refraction as a physical ball, and it's not.
Perfectly said.
Eventually, you can buy my book for $29.99. I'll have all the formulas in it for it. I have all this discussion. The reason why I'm making this book, and I'm hoping to put it out there, it's more of a historical documentation for the last 6 years of everybody involved. Not everybody, but a good, the main characters. It's a story that will tell you the argument. It's a story that will get you to question Kepler, Copernicus, Newton. It's nothing new that I'm writing about, except for it's about us. It's about us on Discord. It's about who we deal with. Bob, Blue. What's that?
I'm gonna buy that book for sure. So let us know.
I keep joking about the $29.99. By the way, I just keep saying it's an arbitrary number. The fact is, I don't know what it's going to cost. I'm going to try to keep it around $20 just to recoup my losses. I've been working on this thing for a few years, and what would you guys like to see in the book, just out of curiosity? Anything?
I'd like to see some more research about covering distances in the southern hemisphere.
Yeah, so what I have in a section, I have Antarctica information. I have a friend who is a professional photographer who works for National Geographic. You'll read about a conversation I had with him and the evidence he presented me for 24-hour Antarctic sun. You'll be quite surprised at somebody who claims to be a professional working for National Geographic, what evidence he presented. I'm not going to tell you. You can read it in the book.
North Pole would be great, too.
North Pole, the only evidence I can get is floating stations, 700 from the apparent position of the North Pole. The closest distance I can find are floating stations about 700 miles from the North Pole apparent position. All the data regarding these stations, I can't find anything. I can't get a hold of anybody for the data, like any kind of angle data, any kind of even a videography work. Let's say the time lapse from the North Pole of the polar rotation from that point. I've got nothing. I can't find anything. So anybody who's got that information, flatearthdata@yahoo.com, just send it to me, man, because I've looked. The only information I can get is from the floating stations. That's it.
Is there any flight paths that go over there?
Not over the North Pole that I know of. No, not directly over. No.
I'd like to see that contradictionary in your book. If you could get, all the contradictions in the globe in like one spot, like the trichotomy we went over last night and the night before.
Yes. Okay. So in all fairness, QE's in the book, Oakley's in the book, but I stick to their ideas. I basically highlight. I have my own argument, right? In this whole movement, I have my own argument, my own math, my own everything. Just like QE has it, Nathan has his, right? Or whoever, Whitsitt has his, or Nathan Thompson has his. We all have our arguments, so to speak. So I've kind of compartmentalized the arguments to specifically those people. The stuff that I've gotten that is the, I guess the doublespeak or inconsistency would be in the Discord section, because what I've done is I've interviewed people so far, and I'm going to keep doing it. So, for instance, I interviewed Jose last year, and I asked him the same question: what causes the apparent junction of the sky and ground? He claimed perspective and yelled it at the top of the roof. A year later, he doesn't want to give me an answer. So those are the kind of things that I write down, and then I verify, and in real time record it and get them to, and then I tell them I'm going to quote them for posterity reasons. So that's what you're going to find, is which you're used to. Like I said, I think I'm just making more of a historical book here, and highlighting the people involved and the the attitudes. Right, I have a section about, it's called beyond the curve. So beyond 33 in the curve, which will give you some pretty interesting information regarding the Masons in the movement of flat Earth.
Well, I'm looking forward to it. Your data is generally very detailed and exquisite, so sounds really good.
Well, I don't know about detailed and exquisite, bro. That's very generous, dude. That's fucking really generous. I've never heard such kind words, man.
Well worded, you get straight to the point, and you generally have extra information that like you don't find elsewhere. I like it.
Can you go over the sources like again? Because I didn't catch the sources. I just came back to the VC.
Sources of.
So what you were just talking about, really, just like where you get your information from. I'm just curious.
Well, there's lots of video watching. There's lots of listening. There's lots of reading. There's lots of question asking. There's lots of PhD physics tutorials, mathematic tutorials, lessons. I'm not certain. Would you like to be more specific?
But I mean, yeah, I'm talking about like higher level physicists, like actual information from space
astrophysicists.
agencies.
So I've reached out to what's her name? She's an astrophysicist. She's well known online. I can't think of her name. Becky. So I've reached out to Becky a few times. I haven't gotten a reply back. I've reached out to Jonah the scientist. He's from Michigan University. He's replied back to me once so far. Who else have I reached out to? There's definitely more interactions scholastically. I've gone into schools and approached instructors and asked questions on the fly. There's many things to find find information.
So I believe that Becky you're talking about is Becky Smethurst, right?
She's an astrophysicist on YouTube.